This is the layout of the process where what we have is bars entering the system and valves getting shipped to the customer, and these bars undergo a series of operations to transform them into valves. So let's take a first look to the saw area, which is the first process that we have in our plant. And what we have is bars arriving to the system every half hour, and they arrive in lots of three. The first arrival happens at time 0. This is not really relevant because we are going to analyze how the system behaves for a whole year. And whether this happens at the very beginning or in 1, 2, 3 minutes is irrelevant because we're dealing with a large runtime or a large uh, horizon to analyze how the system performs. And we have a stock buffer that can only hold 10 bars. So when bars arrive, if there are 10 bars waiting within the buffer, these bars will be rejected and won't be used to produce valves. We have a saw that cuts the bars, into different blocks, into exactly three pieces. So what the saw does is it gets a bar from the stock, it cuts into three pieces, and we have three blocks, and this will be turned later on into valves. And this process takes 6 minutes, although we're not using all the time available of the saw because we have breakdowns. And every 100 minutes on average, following an exponential distribution, we have a failure. This happens every 100 busy or minutes times where the saw has been working. So this exponential distribution is based on the busy time of the saw. This is the same for the rest of the processes unless otherwise stated. And every time we have a failure, we have a repair time that follows a triangular distribution with a mode of 25 minutes and a minimum and maximum value respectively of 10 and 30 minutes. And once we have the bars cut into blocks, we have a belt conveyor which is a 20 feet long and moves at a speed of 4 feet per minute, and this these valves or these blocks are moved from here, from the saw, to the following process. One relevant thing is that the belt conveyor behaves so that if there's no place for the blocks to be processed in the following stage, it gets blocked. It's not a rolling belt conveyor. This will be one of the changes we can do. So if one block gets stuck here because it doesn't have the space or the room in the following process to be processed, what we have is all the blocks we have in the belt stop. And when this blockage finishes and the block we have here moves to the next process, the elements we have in the belt conveyor continue moving till they get to the following process.